Good morning, all of you. In this session, we are going to start with the polymer materials. So this is the continuation of the earlier session where we completed the discussion about the mechanism of polymerization, what is polymer, what is the degree of polymerization. All those topics were covered and available on the channel called World of Competitive Chemistry. In continuation to those topics, today we are going to discuss about nylon 66 extensively. Nylon 66 is the condensation polymer, which is formed by the condensation of two different monomers. One is called the hexamethylene diamine and second is called the adipic acid. Right. So before entering into that session, earlier we completed various videos available and the entire engineering chemistry topics, which are covered with the molecular structure and theories of bonding, water and its treatment, corrosion, electrochemistry. Next is about stereochemistry and advanced spectroscopic methods in engineering sector. In addition to this, 10th class chemistry and physics, all those topics available on the channel called World of Competitive Chemistry. We completed entire CSR, NET, JRF question papers since 2014 to till 2020. So here all these topics are available on the channel called World of Competitive Chemistry. In today's session, we are extensively discussing about the polymer that is nylon 66. Nylon 66 is the condensation polymer which is formed by the combination of two different monomers. Always condensation polymers gives rise to the product with the byproduct formation. That's a compulsory condition. And moreover, there should be a different functional groups on their terminal centers of the monomers. Hence, always the condensation polymer generated will be a copolymer, which is a heterogeneous polymer formed from the different kind of monomers here. Adipic acid is one of the monomer consisting 6 carbon atoms in its carbon chain and the hexamethylene diamine. So here hexamethylene diamine is another monomer. Again, it is composed of 6 carbons and 2 amino functional groups on their side chains. So these active functional groups will condense in such a manner by the removal of water, which is in chemistry, it is designated as a dehydration process, where removal of water molecule is possible in between, so that here it turned into a amide functional group. Always condensation of carboxylic acid with amine gives rise to a amide functional group. Hence, it is a nylon 66 is a polyamide, because such amide groups will be repeated for several times, being it is a polymeric moiety. So here polymer formed will be a polyamide, and the one terminal composed with a repetition of a C double bond group in either terminal is composed of NH group. These will be extended for several times. That depends upon the degree of polymerization involved in here. Now let us see the introduction for this nylon 66. Nylon 66 is made up of repeating units linked by the amide bonds. The functional group involved in this nylon will be amide. Amide gives the C double bond or NH functional group over here, and frequently referred to as a polyamide. So here repetition of these amide units, so we can say it is a polyamide. Nylon was the first commercially successful synthetic polymer. So within the laboratory synthesized polymer will be a nylon 66. It is the first introduced synthetic polymer. Nylon fibers are used in many applications. We already familiar with the applications of nylon. Our toothbrush bristles are made up of this one. Nylon nets are available for fishing, and nylon nets for sports purpose we are using. Nylon fabrics will be there, clothing will be there, waterproof nylon clothing will be there, carpets are available, and musical strings, ropes, all these made up of nylon polymer itself. And solid nylon is used for the mechanical parts such as machine screws, gears, and other low to medium stress components previously cast in the metals. Earlier, most of the automobile parts are made up of metals and their alloys only. Nowadays, they are replaced with the nylon, being nylon is a very strong material and resembles in the strength on par with the metallic component. That's the reason why now these components replaced with the convenient nylon materials, machine screws, gears, and other stress components. All these are manufactured and fabricated with these nylon polymers. Nylon 66 also refers to as a nylon 6 comma 6. Why it is mentioned like this? Because the one of the 6 indicates the carbon atoms present in the first dicarboxylic acid. This is denoted as a dicarboxylic acid. Let us count number of carbons which are represented over here. 1, 2, 3, 4, 5, 6 carbons. The second one, monomer is composed by diamine, where 2 terminals are composed with the amino functional groups. Hence, we can say it is a diamine. Here, 1, 2, 3, 4, 5, 6 carbons. So here 2 monomers are having 6 carbons respectively. Hence, we can say it is a nylon 6,6. Polyamide generated from the nylon class. Nylon find many applications, and the 2 most common textiles, plastics industries are nylon 6 and nylon 6,6. So most of so many type of nylons are available. That depends upon the number of carbons present in the given monomers. Here, for example, nylon 6 is there, nylon 6,6 is there, nylon 6,10 is also there. So among all these, nylon 6 and nylon 6,6 found familiar and most common applications because of their durability and also another advantageous characteristics. The polymer is made hexamethylene diamine, and another one is called ADEPIC acid. Here you can clearly observe this diamine is called hexamethylene diamine, and this diacid is called ADEPIC acid. Dicarboxylic acid it will be. Total 12 carbons are resided in this polymer. Whenever these 2 units get combined, that will be repeated for several times. So here 6 carbons of carboxylic acid and either 6 carbons of amine are the reason for its naming. Now, this is about the crystal form. So here, whenever the nylon got crystallized in such a manner, there is a formation of hydrogen bonding between the units, so that here nylon will be arranged. Always crystalline structure is nothing but highly systematic arrangement, the 3-dimensional regulation. That is called the crystalline nature. So solids may be present in different forms, but crystalline nature is nothing but high regularity will be there. So whenever nylon persisting its crystalline structure, highly regular arrangement will be retained. So that crystalline nature will be mentioned in the structure, where we are having nitrogen with the hydrogens on their side chains, and these carbons are arranging in certain manner that is in highly regular order, and the growing chains are combined. They get attached with the weaker hydrogen bonding, so that here they are existing in the solid form, and moreover high regularity will be retained by this molecule due to such hydrogen bonding formation. And here are the some of the glimpses regarding the physical properties of these nylon molecules. Nylon 6,6 has the melting point of 265 degrees centigrade. So comparatively, the value will be extremely large. That is purely because of 2 reasons. One is high molecular weight, obviously higher will be the melting point. And the second major reason will be the presence of that hydrogen bonding between the C double bond of oxygen and hydrogen of this amine functional group, so that here weaker bonds are generated. Hydrogen bond will hold growing chains, so that here in order to separate we need to rise the temperature. That's the main reason for this high temperature of melting for these nylon 6,6 molecule. And these polymers are resistant towards heat, and friction enables to withstand the heat setting and twist retention. Whenever rising the temperature, it will withstand for the high temperature conditions. Hence, it is a heat resistant, thermal resistant material. Even friction, even we are applying the force without deformation, it will withstand, so that your heat and friction resistant properties will enable these molecules, enable these polymers to find the wide range of applications in industries, and even they will replace metals because of their such a kind of tough and high resistant towards the load applied from the external source. And even for high temperature, they will resist, so that here whenever high temperature conditions, heating conditions are there, in that case also we can apply them. Its longer molecular chain results in more sites of hydrogen bonds. As long as we are increasing the chain length, more number of sites are free for such hydrogen bonding, so that firmly bonded, and that will impart the strength and toughness to these molecules. This means that nylon 6,6 is difficult to dye. Means difficult to dye in the sense dyeing property, that means coloring property in order to color these nylons. It's a difficult process, but it is possible. But once dyed, it has a superior color fastness and less susceptible to fading from the sunlight, ozone, and even yellowing from the nitrous oxide. So dyeing is a certain extent, it is a difficult to process, but whenever dyeing was completed, it will firmly bound to them that what coloring agents, pigments will strongly affirm to them, and fading of those colors, shading of those colors, and even change in the colors, those are not possible even the sunlight and the exposure to the chemicals. So color persistent property is extremely large for these nylon materials, especially in the fabrication purpose. Nylon 66 has up to 36,000 psi tensile. Tensile strength is nothing but whenever we are applying the load, how extent it will withstand, how extent it will bear that, that is called its tensile strength. And flexural strength is also extremely large. 50,000 psi units will be there, and the lower expansion, even by the application, that will not spread. Better dimensional stability in the sense it will not lose its dimensions. For example, if you are taking the nylon container, so that nylon container for you used for several years, several days, for example, so its shape or that dimension will not be deformed even after certain days. So that is the dimensional stability. Even by applying the force, it will not lose its structure, its dimension will not be varied. And improved thermal conductivity. So it used to transfer the heat from one place to another. That is denoted as a thermal conductivity. So thermal conductivity property is also there. Electrical conductivity property is also there for these nylon 66 materials. Especially here, the topic we have to consider is a high melting point. That's the reason why it will withstand for high temperature conditions, and the heat resistance will be there. And friction resistant, even rubbing, even machinery, any machinery is moving on the surface of this one, it will not deform. It is more durable in nature. In fact, it is composed with the hydrogen bond. That's the reason why its additional strength is added to these nylon polymers. Now let us see overall chemical equation pertaining to this nylon 66 formation. So here one of the hexamethylene diamine moiety, and another is either we can take dicarboxylic acid, or else its derivative form can be taken. I'm taking acid chloride. Diacid chloride was taken where hydrochloric acid is removed as a byproduct, so that here amide linkage is generated in between, and one of the monomeric part is consisting 6 carbons in either also resided with the 6 carbon atoms. Finally, nylon 66 is originated with the NHC double bond amide linkage. A number of repeated units get combined so that a long chain polymer is obtained, and we are familiar with the nylon nets, which are available in the sports grounds as well as in a fishing purpose. Another is about let us know about the important specific characteristics of these nylon materials. Because of these specific characters, they are finding versatile applications in industry, household, and even automobiles. Variation of luster. So here all nylons are not having lustre tendency or shining tendency. That depends upon the type of materials blended with them. Some are lustrous in nature, some other semi-lustrous, and even dull shades also available in these nylons. Durability. So nylons durability is extremely large because of the affirming hydrogen bonding that will induce the stability for them, so that a long-standing and high tenacity will be there. High tenacity denotes what affirming tendency, binding tendency, and the deformations will be extremely small. Consequently, durability is extremely large. High elongation, even we elongate these to the longer extent. That's the reason why very thin fibers we can elongate like threads. So not even the plastic material, plastic rods, plastic containers, but also a thin thread can be made by using this nylon. That's the reason why they are most important materials in the textile industry, because of this elongation property. And excellent abrasion resistant, even by applying the friction or force from the external source, they can withstand. That is called abrasion resistance. Without erosion, that remains, that withstand. So here abrasion resistant is extremely large. That's the reason why friction conditions can be minimized. Highly resilient, being nylon is a heat set material, heat resistant material. Once it's set into particular dimension, after heating, it will not deform, it will not change its shape, because thermoset plastic, in the sense, whenever it is transformed into a particular dimensional shape, so that will pertain to that shape, and durability will be extremely large. These are very hard and tough materials. Pave the way for easy care garments. So already we know, being elongation is extremely large, they are threading agents, so that garments are textile industry. So we are using the synthetic fiber for the manufacturing or fabrication of clothes. High resistant to insects, fungi, animals, as well as molds, mildew, rot, rat, and many other chemicals. Even the exposure to nitrogen oxide, color will not be faded. And moths, as well as insects or fungi, whenever in contact with nylon, they may not react with that one, they may not damage that, in fact. Used in carpets and nylon stocking, right? So here nylon carpets are most familiar for us, and they are made up of these polyamide moieties. Nylon stocking will be valuable. This is also kind of application for these nylon because of high advantageous characteristic properties. Melts instead of burning. Whenever heated to extremely large temperature, that solid material will become soft, molten state rather than burning. So it will not catch the fire, rather it will melt, and that becomes a soft material. These are the characteristics in different dimensions given for these nylon 66 polymer. Then how can we manufacture this one? Let's make nylon 66. Nylon 66 is made by combining condensation of hexamethylene diamine with the adipic acid. Hence, we can denote as nylon 66, a total of 12 carbon atoms that denotes the name nylon 66. Just to be recollecting the topics which are earlier discussed. Hexamethylene diamine and adipic acid are combined with the water in a reactor. We are taking a stoichiometric ratio of hexamethylene diamine and adipic acid. These are the monomeric units required to generate the polymer, and they blended with water, being both are polar organic compounds. They can be easily water miscible, and they are mixed in the reactor. This produces nylon salt. So because here we are taking, one is base and either is acid. Amine is the base, acid is the acidic compound, adipic acid is the acid. Acid base gives rise to a salt. That's the reason why whenever acid base mixed with water, there is a formation of obvious salt is possible. Nylon salt is then sent to the evaporator, where excess water is removed. Wherever water is there, that water get discarded by evaporator, where rising temperature to more than 100 simply to remove the water from that container. Nylon salt goes into a reaction vessel where the chemical process makes molten nylon 66. So here polymerization container. So after drying, so this nylon salt now poured into the polymerization chamber. So here chemical process will be possible, that will be treated with the suitable chemicals, makes the molten nylon 66. Entire compound now turned into a molten. So because in order to fabricate, in order to mold into different whatever dimensional shape we require, it should be in the molten state, flexible form. So here molten compound nylon 66 got generated. The molten nylon 66 undergoes a spinning process. Now it will be spun, because most wide applications found in the textile industry, so it will be spun. Now, where the nylon 66 excluded, sent through the spinneret, which is a small metal plate, fine holes. The nylon is then air cooled to form the filaments. right? So whenever these are passing through the fine holes, very small holes will be there, through that they are supposed to move. So being these are highly elastic in nature, elongation is possible, and they turned into such kind of threads, because we are passing through the fine holes, very small teeny holes we are passing. That's the reason why nylon threads will be obtained after air cooling of this one. This is the entire process of manufacturing. This is a unit of polymer manufacturing where nylon will be generated finally. So let us find the applications for these versatile polymers. Nylon can be used as a carpets. So nylon carpets are available right now. And apparels, so many kind of garments are available which are made up of these nylon. Even these are waterproof in nature. So in either say here, this is a carpet you can find, and these are the ropes which are made up of nylon, and the garments which are fabricated by nylon. Airbags are available, which used to retard, which used to prevent the accidents in the road transportation system. And conveyor belts are made up of, conveyor belts are used for the industrial machinery. In industrial machinery, we are using these conveyor belts. Even in the airports, we are using them. So these are also made up of this nylon polymer and hoses in order to transport the gases. And these kind of hoses can be made up of nylon polymer. Fishing nets and other nets also made up of this. Nylon 6 longer molecular chain, denser structure qualifies it as a premier nylon fiber, specified most often by the professional architects and designers for use in the commercial settings like offices, airports, and other places that a lot of wear and tear. Because of its wear and tear resistance, even by applying the food, that will not be deformed. Hence, we are applying so many regions like offices, airports, and other places as well. Also, an excellent choice for the residential carpet applications. So such kind of carpets also made up of these nylon materials. In multi-dimensional ways we are applying, and even nylon fiber tires are available here, you can find. So along with the rubber tires, these nylon tires also available. So in so many ways nylon is applicable. Let us recollect all the topics whatever we discussed in this session. So today's session purely for this nylon 6,6 polymer only. Nylon 6,6 is the polymer which is formed by the condensation polymerization of two monomers. One is called hexamethylene diamine, second is called ADEPIC acid, one is the diamine, second is dicarboxylic acid. Right. So because of its various versatile characteristics, it find the applications here, special kind of applications in the various fields. Right. So in this session, we gone through the detailed description about the manufacturing of nylon 6,6, how can we manufacture this nylon 6,6, and how we find the applications, and what are the important physical properties, characteristics, and also applications in various fields. All these topics were covered. So hope this session will be helpful for your preparation. Thank you very much for your consistent listening. Thank you one and all.